Good day everyone, I am Kristine Josh. I am a grade 11 student. And for today's video, we will discuss about some examples of domain and range. Here's our objective. First, I want student viewers to enjoy, understand now and learn what is domain and range. Then students, viewers will be able to define our now the differences of domain and range. And lastly, for them to learn about domain and range and the following examples of each application. So, do you know any idea what is domain is? Domain is a first set of a number and also the set of each possible inputs and the value of x. How about range? Do you have any idea what this range is? Range is the second set of a number, the set of its possible inputs, outputs, and also the value of y. So the first example of our domain and range is a table of values. This is x, which is our domain, and this is y, which is our range. So my first question, as we can see, when we write and arrange our domain and range, the first number we write is -7, while the given in the table of values starts in -3. Why is that so? If we deserve -1 is the last negative numbers when moving to the right side, so it's important thing to know about negative numbers is that they get smaller the farther they get from 0. Therefore, -7 has smaller value than -3. So our domain is -7. So our domain is -7, -5, -3, and 8 and 9. And same process of our range. So our range are -8, -4, and 7. The second examples of our domain and range is ordered pairs. Do you have any idea what an ordered pair is? Ordered pair represent the function of the domain and range. They will always consist of two numbers that are paired to one another. For example, 1, -3, -2, 4, 3, -6, -5, -1. Our domain here is 1, -2, 3, and -5. But if we will start arranging our answer must start negative numbers. So we have -5, -2, 1, and 3. So what if our ordered pairs are all positive? Do we still need to arrange it? Of course, we still need to arrange it, but the arrangement will be more easy. We will just write the smallest to highest numbers. So we have 2, 3, 5, 9, 6, 7, 7, 2, 8, 10. Our domain will be 2, 5, 6, 7, and 8. While our range will be 2, 3, 7, 9, and 10. The next sample is graph. In the example we are using now a graph. The question is how do we find the domain and range? Okay, so first the domain of the graph is in horizontal line, which is the x value, while the range is in line, which is our y value. So now that we already know the x and y values and how to find our domain and range. So in this example, the domain of the graph is -6 and 1. When the circle dots are shaded, that means they are counted or being part of the solution. Therefore, x -6, x -1. X such that x is greater than or equal to -6, but x is less than or equal to -1. How about the range? It's a same process but different area. To find the range, go to y-axis which is the vertical line. So there are 1 and 5. Therefore, x1, y5, y such that y is greater than or equal to 1 but less than 5 or equal to 5. X squared plus y negative 8. To find the domain, solve for y. X squared plus y equals 8. Y equals 8 minus x squared. The x squared are being transferred to the right side next to the positive 8. How do we find the example of x? So there it is. X equals 1. So y equals 8 minus 1 squared. Multiply the number by itself, which is 1 times 1, and the answer is 1. So that y equals 8 minus 1 is y equals 7. Therefore, the second, 2x, x, x such that x is the elements of real numbers. How do we find the range? To find the range, solve for x squared plus y equals 8. To find the number, to find the x, solve for square root method. X squared equals 8 minus y. So x equals square root of 8 minus y. Y is equal to positive or negative square root of 8 minus y. So that y such that y is greater than or equal to 8. On the next example, x squared plus y minus 10. To find the domain, solve for y. X squared plus y equals 10. Y equals 10 minus x squared. Some process of our previous example. Let x equals 2. So y equals 10 minus 2 squared. Then multiply 2 by its number, which is 2 times 2 is equals to 4. So y equals 10 minus 4. The answer is 6. Therefore, the domain is x such that x is the elements of real number. And then proceed to the next process. To find the range, solve for x. X squared plus y equals 10. X squared equals 10 minus y. Y is being transferred to the right side. So that x equals square root of 10 minus y. X is equal to positive or negative square root of 10 minus y. 10 minus y, 0. To binary greater than or equal to 0. So therefore, y must be y. 10, so y greater than 10. So y such that y is greater than or equal to 10. That's all for today's video. Thanks for watching. Bye bye. Please click the subscription button and tap the notification bell for more videos.